Hello. Shall we talk about the leather question, which is related to the mechanics part of the A-level maths? So question 12, it says, a uniform leather of mass 20 kg rests with one end on a rough horizontal ground and the other end against a smooth vertical wall. We shall pause right there and try to draw it out. It says it's a uniform leather. It also says it's 20 kg. So I'm going to label it out right here. It says 20g, which is the weight of the leather. And then it says it's a rough horizontal ground, which means there is going to be a friction. Let me label it out. For the vertical wall, it's smooth, so there's no friction there. We don't need to worry about it. And then it says the leather makes an angle of 60 degrees with the horizontal and is on the point of slipping. If it's on the point of slipping, that is the moment we have friction equal to mu times reaction force, which I'm going to label it here. That's R1, and here that's R2, and this is 60 degrees. Okay, I think that's all the forces that we have. Let's move on. For part A, it says, show that the coefficient of friction between the leather and the ground is square root 3 over 6. In order to figure out the coefficient of friction, we need to do different steps. One of the steps involves all of the forces that we have, because the uniform leather is currently on the point of slipping, means it's not moving yet. That means all of the force will be able to cancel each other out, horizontally and vertically in this case. Let's do that first, before we move into the moment. So shall we say that vertically, R1 equal to 20g, horizontally, R2 equal to F, equal to mu times R1. And then let's try to combine them together. R2 equal to F equal to mu times 20g. How do we figure out R2, or how do we figure out the friction? We have to write out the equation for the moment. We are going to use this point A as the pivot. So if A is the pivot, we got two moments that we need to take into consideration. One is the moment for the 20g, the other one is the moment for the R2. Let's do it together. So in this case, the clockwise moment would be 20g times, we need to figure out the perpendicular distance. In this case, I don't think we know the total length of the leather, so let's just assume the total length is L. I'll show you guys what I meant. This is L. So this part is half L. That part is another half L. And in order to figure out the perpendicular distance, which is this part, and in this right angle triangle, 90 degree, 60 degree, 30 degree. This is a lovely triangle that we have learned in math before, by the way. This is half L, so the base will be a quarter L, based on the trigonometry. And let's keep going with the procedure. 20g times a quarter L equal R2 times, let's figure out the perpendicular distance of R2, shall we? It is this part. And once again, we got a 30 degree, 60 degree right angle triangle. 60 degree, right angle, 30 degree. This part is L, this part is half L, and this part should be square root 3 over 2L. And then let's keep going. On both sides of the equation, we can cancel out the L, which is going to turn it into 20g times a quarter equal to R2 times square root 3 over 2. We can simplify the equation by multiplying both sides of the equation by 2. And we're going to have 2 times 20g times a quarter equal to R2 times square root 3 over 2 times 2. We're going to get square root 3 R2. And on the right hand side, we'll get 10g. So R2 in this case will be 10g over square root 3. Now that we figure out R2, let's substitute it back into that equation there. 10g over square root 3 equal to mu times 20g. On both sides, we can cancel out the g. 10 over square root 3 equal to 20 mu. Mu, in this case, will equal to 10 divided by 20 square root 3, which would give us the final answer, 1 over 2 square root 3. And we can then simplify that into square root 3 over 6 by rationalize the denominator. Okay, so there we go. That's how we got the answer for part A. Let's move on to part B. Alright, for part B of the question it says, a person of mass 60 kilograms stands 3/4 of the way up the ladder. That is the 60G. Find the magnitude of the minimum horizontal force must be applied to the base of the ladder to keep it in limiting equilibrium. It seems like the ladder is going to slide towards the left-hand side unless we apply a force at A towards the right-hand side. And I suggest that we do the same thing as before. We should write the equation vertically. We should write another equation horizontally. Both of the equations are related to the forces that we have in the diagram. And because the ladder is in limiting equilibrium, at this moment we can write F, the friction, equal to mu R1. So, vertically, we got R1 equal to 20G plus 60G. Horizontally, we got R2 equal to the friction plus the force that we applied. Let's simplify each of the equation. R1 equal to 80G and R2 equal to mu, in this case we know it's square root 3 over 6, times 80G plus the force that we applied. Simplify it further. R2 equal to 40 square root 3 over 3G plus the force F. Now that we've finished writing the vertical and horizontal force equation, we need to move on to the moment equation in order to figure out what is R2. And you'll find this part very familiar. Moment. We still set A as the pivot. A is the pivot. We got the clockwise moment, the 20G and the 60G. We got the anti-clockwise moment, the R2. Let's do it one by one. 20G times the perpendicular distance for 20G. Remember what we have done before? That was 1/4 L. The perpendicular distance for 60G is going to be half of 3/4 of L, which equal to R2 times, again, remember what we have done before, square root 3 over 2 L. Let's simplify it further. 5GL plus 45 over 2 GL equal R2 times square root 3 over 2L. We can cancel out L for each of the term. 5G plus 45 over 2G equal to R2 times square root 3 over 2. If we do a rearrangement, R2 equal to 55 square root 3 over 3. Now that we know how much is R2, we need to substitute it back into that equation. 55 square root 3 over 3G equal square root 3 over 6 times 80G plus F. In that case, F should equal 5 square root 3G. G is 9.8, which is why F equal to 84.9 Newton. 3SF. And guys, that's pretty much it for this question. Rather long question and difficult at the same time. But if you remember how to do the moment, how to resolve the force, then I think we can do the question. And then let's move on to question 13. It says, a uniform leather of mass 25 kg, which is labeled out on the screen, and a length 9 meter, rests on one end on rough horizontal ground. Okay, this is the moment that I need to label out the friction. And the other end against a smooth vertical wall. Well, once again, we don't really have a friction for the vertical wall because it's smooth. The leather makes an angle of 68 degrees, which they label it out, with a horizontal. A window cleaner of mass 76 kg stands 2/3 of the way up the leather, which is labeled out, and the leather is in equilibrium. That means all the forces acting on leather, they can cancel each other out. Could we find a range of possible values of the coefficient of friction between the ground and the leather? Well, in that case, shall we try to label out all the forces that's acting on the leather at this point? There's a normal contact force. There's another normal contact force. First of all, let's write out the vertical force equation and the horizontal force equation. Vertically, R equal to 25G plus 76G, which then equal to 101G. Horizontally, normal contact force equal to the friction. But let's keep going. Because they are asking us to figure out the range of possible value of coefficient of friction, then we need to think at this point, right, on the point of moving, or at a point of limiting equilibrium, F equal to mu R. So shall we write N equal to mu R? And then let's keep going. We just figured out how much is R, and let's substitute it in. N equal to mu times 101G. Looking at this equation, bear in mind that the question is interested in the coefficient of friction. So if we can figure out the reaction force, which is labeled out as N, then we can figure out the coefficient of friction, which is labeled out as mu. And how do we figure out the reaction force? I think we have to use the moment equation. I'm going to write it on the very top. Moment. We are still going to use A as the pivot. A is the pivot. The clockwise moment is 25G and 76G. 25G times, we need to figure out the perpendicular distance in this case. I'll show you guys how we are going to do that. This is the perpendicular distance. And in total, the length of leather is 9, which is why it's 4.5 meter here. So the perpendicular distance, d over 4.5, equal to cosine 68 degree, which is why d equal to 4.5 times cosine 68 degree. 4.5 times cosine 68 degree. And then let's keep going. We still got the 76G as another clockwise moment, plus 76G times, in this case it's not 4.5 anymore. Let me change to another color. We have this right angle triangle right there. So the question told us it's 2/3 of the way. 2/3 times 9, that would give us 6 meter. So in this right angle triangle, the perpendicular distance divided by 6 would equal to cosine 68 degree. So in this case it's 6 times cosine 68 degree. And this would equal to the moment of the anti-clockwise force, which is labeled out as N. And we need to figure out the perpendicular distance of the force N, which is right here. And this is 68 degree. It seems like that the perpendicular distance of N divided by 9 equal to sine 68. So in this case, we're going to write 9 times sine 68 degree. Now that we got it in the equation, we are going to put everything in the calculator, figure out the value of the N. Equal to 250.1 Newton. Now that we get the value of the reaction force on the vertical wall, we have to substitute it back into this equation. 250.1 Newton equal to mu times 101G. Mu equal to 250.1 divided by 101 divided by 9.8, which gives us the final answer, 0.25. Alright guys, I think that's it for these two difficult questions. Please like and subscribe. I'll see you guys next time. Bye bye.